Hello and welcome to our first topic, which will be arithmetic, the study of numbers and the operations between them. The subtopic of arithmetic that we'll be going over today would be integers. What are integers? Integers are the numbers 1, 2, 3, and so on, and their negatives. So we can write the set of integers as 0, 1, 2, 3, and so on. That dot 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 means going on forever. And negative 1, negative 2, negative 3, and so on, going on forever in the other direction. So these are our set of integers. Now, there are two categories of integers, either positive integers, which I'll represent by plus, and negative integers. Negative integers include numbers like negative 3, negative 2, and negative 1. And then positive integers are like 1, 2, 3. There's actually one more type, but this type only includes one integer, and that is the neutral type, which is a number that is not positive and not negative. The only number that falls into that category is 0. Next, we'll talk about how you can multiply integers. So the product of two positive integers is a positive integer. So plus times plus would be a positive integer. And an example of that would be something like 2 times 2, which is 4. And then negative times negative is also positive. So an example of that would be negative 2 times negative 3 equals 6. Lastly, a positive integer times a negative integer would be negative. An example of that would be negative 3 times 2, which is negative 6. Okay, great. Now let's talk about divisors or factors and multiples. So, what are factors? Let's pick a random integer. Let's pick the number 15. What are the factors of 15? The factors are the numbers that we multiply to get 15, and all of those numbers are considered factors. So how can we get 15? What are the ways we can get 15? Well, we can do 1 times 15. Also, we can do 3 times 5, and that's pretty much it. So the factors of 15 are 1, 3, 5, and 15, and that's just from least to greatest. Now, what are multiples? A multiple is the product of a number and an integer. So let's see, can 10 be a multiple? Yes, because 10 is equal to 2 times 5. So 10 is a multiple of 2, and 10 is a multiple of 5. Okay, so let's just go over this one more time. What are the factors of, let's say, 20? Factors of 20 would be 1, because 1 can go into it evenly, and 2, and 5, and 4 also, and 20. So these are the factors of 20. Now, what are the multiples of 2? What are the multiples of 2? So we have 2. 2 times 2 is 4. 2 times 5, that's 10. So you can keep on going. Alright, so those are some pretty simple concepts. Now I want to go over two more concepts that I'll explain in just a second. So they include, let me just erase this part here. So they include least common multiple and greatest common factor. Okay, so let's go over least common multiple first. What does a least common multiple mean? And I'll be abbreviating least common multiple as LCM. So the least common multiple of two numbers, I'll say 2 and 4, are the least common multiple between them. It's exactly how it sounds. It's the smallest multiple between the two numbers. So let's see, what are the multiples of 2? The multiples of 2 are 2, 4, 8, 16, and so on. The multiples of 4 are 4, 8, 12, 16, and so on. So what is the least multiple of both of them that they have in common? So that will be 4, because they both have multiples of 4, and 4 is the least one. Okay, great. So now what about greatest common factor, as I said I would do? So greatest common factor. You can sort of guess what that is. Instead of actually talking about multiples, we'll be talking about factors. So I'll do the same thing. What is the GCF, or greatest common factor, of 2 and 4? Well, what are some factors of 2? The only factors we have are 1 and 2. And what are some factors of 4? The only factors we have are 1, 2, and 4. So what is the greatest factor that they both have in common? And that is 2. It's not 4 because 2 does not have a factor of 4. Great. So just get used to this syntax, GCF and LCM, as we'll be using it later on. Now, there are two other concepts I want to go over, and then we'll move on to our problems, which I'll try to have in every single video to test you guys. Okay, so let's see. What can we do now? We can talk about remainders. Remainders. So let me give you two numbers. We have 15 and 6. So I want to do 15 divided by 6. So what is 15 divided by 6? Well, 6 can go into 15 two times to make 12 with the remainder of 3. And all that means is 6 times 2 equals 12, but we're not quite at 15 yet, so we need to have a remainder of 3. And the remainder I'll write as r. And the technical way of writing 15 divided by 6 would be 2 with the remainder of 3 over 6. 2 is what is known as the quotient. Okay? And the 3 we know is a remainder, so I'll write that here, remainder. And 6 is the divisor. It's the number that we're dividing into 15. Okay, so let me give you one more example. How about 20 divided by 3? That would be, well, 3 can go into 20 how many times? It can go into it 6 times. So 6 times, and then what is the remainder? Well, 6 times 3 is 18, so there's a remainder of 2 over the original divisor, which is 3. Okay, great. And just one more. How about 30 divided by 3? Well, 3 can go into 30 evenly. There is no remainder, so it is just 10. No remainder, remainder of 0. Okay, guys, great. And the last one I wanted to go over, the last concept, is prime numbers. Okay, great. So let's talk about prime numbers. What is a prime number? I'll give you the smallest prime number you can ever have, and that is, and so just means number, so that is 2. 2 is the smallest one you can ever have. And the next prime number is 3, and then 5, and then 7. Let's see if we can find a pattern. The only divisors of 2, or the only factors of 2 are 1 and 2. The only factors of 3 are 1 and 3. The only factors of 5 are 1 and 5, and the same thing for 7. So a prime number is a number where the factors are only 1 and itself. So the factors of a prime number should only include 1 and the actual number itself. I'll write it as itself. So I'm going to give you a list of numbers, and you need to tell me which ones are prime. How about 2, 8, 19, and 1? Which one of these are prime? Well, 2 we know is prime, is the smallest prime number. 8, we have a divisor of 2 and 4. So that is there are more divisors of 8 than just 1 in itself. So this cannot be considered a prime. How about 19? Are there more divisors than 1 and 19? No, no other number can go into 19 aside from those two numbers. And 1, even though the divisors are 1 in itself, we said that the smallest prime number is 2. Okay? So 1 is not a prime number. Every number that is greater than 1 can either be a prime number or a composite number. So we know what prime numbers are, and we can just make a simple definition. The composites are any other number that is not prime. All right, so I want to show you guys one cool thing you can do with prime numbers. It's actually really, really interesting. If you take any number and you say that you want to give that number prime factorization, this is how you would do it. So let's pick the number 60. We can break down 60 into a whole bunch of factors, and you'll see that 60 can be written as the product of only primes. And let's see how we would do that. Just give me two factors of 60. Let's do 12 and 5. Any two factors. It could have been 3 and 20. We'll still end up with the same thing. So 12 and 5. What are the factors of 12? We have 3 and 4. And what are the factors of 4? We have 2 and 2. And then what are the factors of 2, we have 1 and 2. And the same thing for this 2, 1 and 2. And then 3, we have 1 and 3. Now what about the 5? We have 1 and 5, and that's it. All this means is that 3 times 4 is 12, 2 times 2 is 4, and so on. Okay, we look at the last branches, the last numbers, the ones on the bottom. So this guy, these guys, and these. And let's write them out. So that's 1 times 3 times 1 times 2 times 1 times 2 times 1 times 5. And I promise you that these are prime numbers, and when you multiply all of these prime numbers, you get our original number of 60. 1 times 3 is 3, times 1 times 2 is 6, times 1 times 2 is 12, times 1 times 5 is 60. And a short way of writing this is to not include all of these 1s. So you just include 1. So 1 times 3 times 2 times 2 times 5. And that is a prime factorization, breaking down a number into the product of only its primes. Alright, so I'll just write the title lastly of prime factorization, so just make sure you know that. And in the next video, I'll go over some problems dealing with the topic of integers.
Take a full GRE practice test right now, completely free at argoprep.com.